Bismillahirrahmanirrahim. Dear students, I am Shafqa Shahidul Chandabaloj, lecturer in Department of Basic Science and Related Studies, Mehran University of Engineering and Technology, Jamshoro. In this series, we are going to discuss the subject linear algebra and analytical geometry. Bismillahirrahmanirrahim. Assalamu alaikum. Dear students, this is the lecture 5 of the series linear algebra and analytical geometry. The topic of today's echelon and reduced echelon matrices. Before going to this topic, let us give a brief description what we have discussed in the last video or lecture number 4. There was the elementary row operation, and these operations were interchanging of any two rows, the constant multiple of a non-zero constant or number to a row, and the third one was addition of constant multiple of one row into the other row. So these were the three operations we discussed in the last lecture, that was lecture number 4, elementary row operation. Now in this lecture we will use this operation to find out the two important forms of the matrices, namely echelon and reduced echelon form of the matrices. So the objective of this lecture is know the echelon form of the matrix, know the reduced echelon form of the matrix, how to change or transform a matrix in these forms using elementary row operation with examples. A matrix is said to be in echelon form if all the zero row come below the non-zero row. This means that if a matrix contains a zero row, then all of these zero rows will be below the non-zero rows. That is the first condition. Second condition is that the first non-zero element in each row, and this element is called the pivot element. That is the non-zero element in each row, first non-zero element in each row, and that is called pivot element. This is equals to 1. So second condition is that in each row the first non-zero element must be equals to 1, and then the third condition is then below that one we have all the element, below that leading one, the all the element in that columns are 0. If the matrix has this form, then we say this matrix is the echelon matrix or echelon form of a matrix. For reduced echelon form, only change appears in the third condition, that all the elements should be 0. That may be below and above. All the element below and above this leading one should be 0. So we can define a reduced echelon form of matrix if it can be expressed, or it has the form that all the 0 rows come below the non-zero rows, and then first non-zero element in each of the row, that is called pivot element or leading one, that must be 1, and all the element above and below this leading one in that column should be equals to 0. So these are called the echelon and reduced echelon forms. Let us see some examples and identify whether the forms are echelon form or reduced echelon form. So let's suppose we have the three matrices. In the first one we have the element 1 2 0 0 1 1 0 0 1. Let us find out whether it is echelon form of matrix or reduced echelon form of matrix or not. So the very first condition we have to identify, that is condition number 1. If the matrix contains 0 row, then that should be below the non-zero row. So we can see that there is a not any 0 row. So remove this first condition. Now we will check just two conditions, second and third one. So from second one, the first non-zero element in each row is 1. So now we see that in the first row the first non-zero element, that is 1. In second row the first non-zero element is second element, that is 1, and in third row the first non-zero element, that is also 1. So we see that these are the non-zero element in the first row, second row, third row, the first non-zero element in each row. And the third condition is that all the elements below the leading one in that column are 0. So in the first row the leading element is 1, and below that we have all elements 0. That is satisfying the second condition also. And then in the second row we have the leading element, that is 1, and below that 1 we have 0. That is fine. And in the third row we have the leading element, that is 1, and below that 1 there is no row, so no need to check out the third condition. Now we can say that this matrix is in the echelon form. So this is called echelon matrix. Now let us see whether this has any other condition satisfy the another condition for reduced echelon form. So for that we see that all the elements above and below the leading one in that column are 0. So we just take the leading elements and we will check out all the elements above and below that the leading element are 0. Simply means then all the other elements are 0 in that column. So we see that first element is 1, all the other elements are 0, and then in second or the leading element is 1, but there is 2 and above this element. So we say that this is not a reduced echelon form. This is not reduced echelon matrix. So now let us try out the second one. So first condition is that to identify whether there is any zero row that should be below the non-zero rows. So we see that there is a zero row which appears below the non-zero rows. That is fine. Now we move for second condition is that the first non-zero element in each row is 1. So we see that there is a first non-zero element in the first row, that is 1, and in second row that is also 1, and then below that one we must have 0 for echelon matrix. So there is also appears there that elements below this one we have 0 and below this one we have 0. So this means that this is echelon matrix. Now this is the echelon matrix. Now let us try out whether it is a reduced echelon matrix or not. For that all the element in that column of the pivot element should be 0. So we see that there is 1 and below that all the elements are 0. But in the second row the element below this one is 0 but above this one is not 0, so which it contradicts or not satisfy the third condition of the reduced echelon form of matrix. So because of this three we see that this is not a reduced echelon matrix. So this is the echelon matrix but not the reduced echelon matrix. Let us try out the third matrix having the elements 1 2 0 0 0 0 1 0 and then 0 0 0 1. So we see that there is no 0 row and the pivot elements in the first row that is 1 here, and second row that is 1 here, and third row that is 1 here. So these are 1, and for echelon form the element below this leading one all the elements are 0. So we said below this one we have zeros, and on this below this one we have zeros in second row, and all the elements are below this leading one we have 0, and similarly in third row the leading element is 1 and below that there is no row. So this is the echelon form of matrix. Echelon form or echelon matrix. It is echelon matrix, and furthermore we also see that this also satisfies the third condition of the reduced echelon form. This says that all the elements in that column below and above to leading one are 0. So we say that all the elements below this one are 0, and for this leading one all the elements above and below are 0, and for this leading element all the elements in that column are 0. So now we say that this is the reduced echelon form. Reduced echelon form. So in these three, the only third metric that is echelon matrix, and it also satisfies the properties of the or condition of the reduced echelon matrix. So this is also reduced echelon form of the matrix. So now once you know which form of the matrix is echelon form and which is the reduced echelon form, so now next is to transform this matrix into the echelon and reduced echelon form of matrix using elementary row operation that we discussed in the last lecture. So let us move for this. So let us start with the example. Transform the following matrices in the echelon form. So here we have the first matrix A having the elements 1 2 1 0 0 0 and 2 1 0. So very first thing to transform this matrix into echelon form is the first condition whether A is there any 0 row. So here we have a 0 row which contain all the elements 0. So first we shall interchange this row to the third row because it should be below the non-zero rows. So we shall use the property uh, elementary row operation, that is interchanging row 2 and 3. So when you interchange these two rows by applying this elementary row operation, you will have a matrix, and then that will be equals to with the elements 1 to 1 first row, 2 1 0 in the second row. This is the row third, which is not a change to the and position at the second row, and 0 row is now at the position third row. So this is after applying this elementary row operation. So now the next thing is that we must have the leading element or pivot element, first non-zero element, that is equals to 1 here. Oh, that is already 1, so no need to change this. The next thing is that all the elements in the same column below that leading one should be 0. So now we have to transform this 2 only to 0, and that is in second row. So we shall apply the operation to change this element to 0, that is multiplying the first row of the pivot element r1 by minus 2 and then adding into the second row. So now when you apply this operation, you will get the elements in the first row will be same because this is the row of the pivot element, and then when you apply this operation, the first element multiplying 1 with minus 2 you will get 2, and adding into 2 you will get 0, and then multiply minus 2 with this 2 you will get minus 4, adding into 1 we will get minus 3, and then in the third multiplying minus 2 with 1 we will have minus 2 plus 0 will be equals to minus 2. The third row will be same, having the same element 0 0 0. So now the next thing is that we have to find the pivot element in the second row, that is minus 3, that is non-zero number, first non-zero number in the second row. We have to change this minus 3 into the 1. So how we can do this thing? Two possibilities may be here. The first thing is that if you add minus 3 2 in this, so you will get minus 1. So this is the operation that if you add row 1 into the row 2, then you will have minus 3 plus 2 will be equals to minus 1, and further we can apply multiplying minus 1 by row 2. So this is the first quality, we can apply these two operations to make this minus 3 to 1, or there is another possibility that we can multiply by 1 upon minus 3 to row 2. So let us see which among the following we can do, and that is that which not affect the operations or elements on this matrix. So if you apply this operation, then what will happen? You see that this element 0 and then plus 1 will be equals to 1. So what will happen? There will be 1, and this will terminate the first condition that we just maintained, the first form, that below the leading one in the first row there will be both of these or all of the elements should be 0 in that column. So this will break up this thing, so we cannot apply this operation. So now we can only apply this operation to make this one. So let us apply this operation. So let us apply this operation, 1 upon minus 3 multiplied by row 2. So this is a non-zero constant. We are applying this operation, multiplying a non-zero constant minus 1 upon 3 to row 2. So in the result you will get the matrix. Now this will become the 1 2 1 will be same, the first row will be same, in the second row we have 0 already there in the first element, and then this will become now 1. How this will be equals to 1 when you multiply minus 3 by minus 1 upon 3. So 3 and 3 will be cancelled, minus and minus will be plus, so this will be equals to 1. Now multiply this minus 1 upon 3 to this element minus 2, this will be equals to plus 2 upon 3. And then the third row will be same. So now let us see it in the Echelon form or not. So we see that in the first row the pivot element that is equals to 1, and below that one we have 0, and then second row we have the pivot element that is 1, and below that one we have 0, and on the third row there is no pivot element. So now this is in the Echelon form. So this is our Echelon matrix. So once we have transformed our matrix into the Echelon form, now next question we can continue from this if we want, that can we reduce this matrix into the reduced echelon form. So for that, what are the possibilities or conditions we have to maintain or transform this matrix into the echelon form? So first thing is that all the conditions are same, that is the first thing. The only change is in the third condition that may be made here, that above and below the leading one we must have 0. So there are only two numbers or two pivot elements, two leading elements, one, and the first row there is no above row, so this is the only first row, so we must have 0 below for reduced echelon form. And the next element in the second row, there is a pivot element, there must be a 0 above it and below it, so we have the below 0 as well, so we have to make this 2 0, transform this 2 into the 0. So for this what we can do, so we can use this pivot element to transform this 2 to 0 by multiplying a minus to a additive inverse of this and then getting this result into the first row. So we can apply the operation. So to transform this into the 0, so we shall use this operation r1 plus minus 2 times r2. So see what will happen. The first element of r2 multiplied by minus 2, so 0 multiplied by minus 2, and then add this result into the first element of row 1, that is for the first element, that this will be equals to 1, that will be same, there will be no effect. And then the second element, we have 2 plus minus 2 into 0, and this will make this 0, this will make this 0. And similarly for the third element, for this element, so we will have 1 plus minus 2 times r2, and in r2 we have the element that is 2 upon 3. So now when you apply this, you will get 1 minus 4 upon 3. When you simplify, you will get 3 minus 4 upon 3, and then this will be equals to minus 1 upon 3. So now our matrix will be equals to, so the resultant matrix will be equals to 1 0 minus 1 upon 3, the elements in the first row. In second row we have 0 1 2 upon 3, and in third row we have 0 0 0. So now we can see that the first condition, that 0 row appears below the non-zero rows. The second condition is that the leading one, the first non-zero number, the leading one pivot element should be equals to 1, and below that one we have zeros, and as well as above this one we have zeros. So since there is no above row, so in order to check out for first row and second row, the pivot element, that is 1, and then below and above this one we have zeros, and in third row there is no pivot element. So now this matrix is in the form of reduced echelon matrix, reduced echelon matrix. So this is in the form of reduced echelon form. So let us take another example with this matrix B having the elements 1 minus 1 1 2 1 0 2 and 3 1 0. Now to transform this matrix, the first one in the echelon form and then in the reduced echelon form, what we have to go, or what we have to transform the elements, what operation we have to use. So let us see. So how we can make this first element to 1, because there is no 0 row, no need to find out the 0 row because there is no 0 row. We have to just move forward, the pivot element should be 1. So we have to transform the first element of the first row to 0. So there are two possibilities: either we can multiply first row by minus 1, or we can interchange these two rows. So I am applying the operation that I am interchanging the first and second row. There is also possibility we can multiply the first row by minus 1, that is also possible, but I am applying the first operation, changing these two rows. So now after applying this operation, what we will have, so now the element of the first row will be from the second row 1 0 2, and then the elements of the second row will be from the first row minus 1 1 2, and then the third row will be same 3 1 0. Now next thing is to transform these two elements, the element below this 1 to 0, to transform the matrix into echelon form. So to how we can change this minus 1 to 0, that is simple. I can add this 1 here, this will be 0. And how I can transform this 3 to 0, that is very simple. I can multiply this 1 by minus 3 and then add this result into 3. So this is our pivot element now. So whenever we have to make 0 in an element of any row, so we have to apply the multiple of one row into other row. So for this element, the second row, I have to apply the operation r2 plus r1. That is first operation I will apply to transform this element to 0, and similarly for second operation I will transform this 3 to 0 by applying r3 plus minus 3 r1. So when you apply these two operation, these two elements below this pivot element will be 0. So let us apply these two operations. So remember one thing, that this row of the pivot element, the first element must be equals to 1. So this will be unchanged because we are using this row. This will be same. Now the change will appear on the second and third element, means second and third row. This will be 0 and 0. So let's apply this first operation here. So minus 1, applying this operation, minus 1 plus element from row 1, that is 1. This will be equals to 0. So we have 0, and then we have second element of the row 2, that is 1 plus 0 will be equals to 1. So we have 1 here, and then we have 2 plus 2, this will be equals to 4. So we have 4 here. Similarly, this will be 0. How? So when you apply this operation, we have row 3, the element is 3, and then plus minus 3 times row 1, the element is 1. At this first position, this will be equals to 0. So now this will be 0 here, and then we have 1, the element in the row 2, second element of the row 2, row 3, that is 1. So 1 plus minus 3 into 0, the element of the row 1 is, that is 0 in the same position. So this will be equals to 1. So when you simplify, you will get 1. So we have 1 here. And similarly, 0 on the last element of the third row plus minus 3 times the element of the first row, that is 2. Simplify, you will get minus 6. So we have minus 6 here. So after applying the operation, we get this result. So now we see that our pivot element, that is 1, and below that one we have 0. Now next thing is that we have to transform this non-zero number and the first non-zero number in the second row, that is 1, into 1, that is already in form of 1. We have to just change below this number in that column to 0 to transform this matrix into the echelon form. So how we can do this? We can simply subtract this 1. So if you apply this operation, row 3 plus R2, because the element, pivot element appears in the row 2, so we have to make use of this row. So just subtract this row R3 minus R2. So when you apply this operation, we will have the first row will be same, 1, 0, 2. The first column will be same, and then the second row will also be same, that is the row of the second row of the pivot element for this operation, and then the changes will appear in the third row. So this will be 0. How this will be 0? So when you apply R1 minus 1, this will be equal to 0. So here is the mistake, just replace this by minus 1. So now we see that when you apply this operation on row 3, the second element in row 3, that is 1, minus element in the row 2, that is 1, you will get 0. So this will be equals to 0 now. And similarly, the third element of the third row, that is equals to minus 6. Now apply this operation, minus the third element of second row, that is 4. So now this will give you minus 10. So when you apply this, you will get minus 10. Now we see that we have get two pivot elements, and below these pivot elements, the same column, we have zeros. So now in the third row, that is a non-zero row, and we have a first non-zero number, that is minus 10. Now we have to transform this minus 10 to the 1. So there is only one possibility, because that is the last row, and in that what we can do, we can apply the operation multiplying this by a number to get this to 1. So if you multiply this by a non-zero number, that is minus 1 upon 10 to row 3, so you will get the first row will be same, the second row we have 0, 1, 4, again same, and then the third row we have the last number will be now equals to 1, because minus 1 upon 10 multiplied by 10 will be multiplied by minus 10 will be equals to 1. So now this is in the echelon form. This is in the echelon form because there is no zero row, and then every pivot element, that is 1, and below that 1 we have zeros. So this is in the echelon form. Echelon form or echelon matrix. Now next thing is that can we transform this further into the reduced echelon matrix? So let us see how we can transform this. So to transform this matrix, all the conditions are same. There is only change in the third condition, that the below the pivot element and above the pivot element, all the elements must be 0. So now we see that in the first row the pivot element is 1, and below and above all the elements are 0s. In second row the pivot element, that is 1 here. So all these element below and above this element, that is 0. And similarly in the last row we have the pivot element, that is 1. Now we just change these to 4 and 2 to 0. So for this To change this 2 that is in the row 1, what we can do, we can multiply the third row, that using this pivot element, multiply this by minus 2. So multiply the third row by minus 2 and add the result into the first row. So when you apply this operation, this will be the first operation we shall apply here, that is r1 plus minus 2 times row 3, and similarly after that we shall apply the operation to change this 4 to 0, that is in row 2. So we shall apply row 2 plus minus 4 times row 3. So when you apply these two operations we will get, so now we have get the matrix 1 0 0 0 1 0 0 0 1. Now we see that the three pivot elements 1 1 and 1, and below and above these elements all the elements the ended columns are 0. So now we have get our reduced echelon form. So this is the reduced echelon matrix of the matrix B, or transform from the matrix B. So now similarly, so there are three matrices for you. Transform them into the echelon matrix or echelon form and reduce echelon form. So try yourself. And thanks for watching this video. Kindly share and subscribe this channel if you have not subscribed still. So in the next lecture we will discuss the rank of a matrix by using elementary row operations. So till then, Allah Hafiz.